Hey guys, welcome back to Genius Learning. So I want to take a look at an integral and some of the algebra that you need to know in order to make this type of integral a lot simpler. So I want to rewrite this integral, right, before we do anything to it, but we need to review what I want to rewrite. So the bottom here, right, I want to complete the square on the denominator, which is this. Okay, so from algebra we should know how to complete the square. We divide this number, b divided by 2 squared, and then we put a coefficient out in the front. So this is going to be x plus 1 squared, and then we're going to end up with plus 1. All right, so just to check, this in here is going to end up being x squared plus 2x plus 1, and then you have a plus 1 out here, which makes x squared plus 2x plus 2, which is exactly what we have down here, x squared plus 2x plus 2. Okay, so this right here works out. All right, now let's use that. So let's use that and let's rewrite this integral over here. We're gonna have now, let's put here rewrite, and we're gonna do the bottom half was equal to this after we completed the square. So we have x plus 1 squared plus 1 dx. Okay, so simple u sub. Let's substitute. We got u is equal to x plus 1, du is going to be equal to dx, right? And one more move that a lot of people might overlook is this top one right here can be rearranged to look like u minus 1 equals x. So if I just move this 1 over to this side, it's going to be u minus 1, and that's equal to x. So we're going to need this. All right, so let's rewrite this with the u sub that we made. So we're going to rewrite it with the u sub. So let's put, for the x value, we have u minus 1. So for the x value, we're going to have u minus 1. And on the bottom here, we have x plus 1, which we made u. So it's going to be u squared plus 1 dx. All right, perfect. Now, let's split the integral. So I'm going to write this bottom half with this, and this bottom half with this separately. Okay, so we're going to have the integral of u over u squared plus 1 dx, right? That's this term and this bottom half. And now let's do the second term in the bottom half. So we're going to put minus the integral of 1 over u squared plus 1 dx. Now we're in a much better position to start integrating. All right, so the first term here, we got one more trick up our sleeve, and we can make this into something that will be a lot easier for us. So remember we have ln. So when you have something that is 1 over x dx, right? Now you have an ln situation here, right? But what you need is the top to be the derivative of the bottom. Okay, so what I mean by that is the following. I want this top part to be the derivative of the bottom part. So what do I have to do? The bottom part, the derivative, would be 2u. So I'm going to put a 2 up there in front of the u. And when I do that, I got to put a 2 on the bottom, right? Keep everything else the same. So essentially, all I did was multiply by 2 over 2. So I haven't changed anything as far as the problem goes. I just put a 2 over 2, which is equal to 1. But it'll allow me to do something now with this integral that I can solve a lot faster. And the other one, I'm just going to rewrite it again. Okay, so now this one is pretty clear to see. It's going to be an arctangent. And here, now the integral is going to be ln. So let's take a look. We got 1/2 that stays outside. Right, and then the integral of this here is ln. So we're gonna put ln, and we're gonna put, for now, we'll just put u squared plus 1, and then over here we have arctangent. So it's gonna be minus arctangent of u, everything plus c, right? So what did we make u? We made u equal to x plus 1. So let's write x plus 1 here, and we can FOIL it out. We'll have 1 over 2 ln of x squared plus 2x plus 2. So all I did was FOIL the the x plus 1, which is what we made our u, and then plus the 1, made that 2. And then minus arctangent of x plus 1 plus c. Alright, so that's going to be our final answer right there. So a couple little weird tricks, but they really help you out when you know them or you can see them. Multiplying 2 over 2, making this look like an ln. So it's just an easy jump into an ln integral, and then arctangent by splitting up this situation over here. You want to split these type of integrals when you can, and multiply it by numbers if you need to. Just make sure that if you do it to the top, you have to do it to the bottom. And that's it. Thank you for watching.